it's Gabrielle, and this video is a sample from Studyclix Boost, our new rapid revision tool. Go to studyclix.ie/boost to find out more.
Hey folks, it's Stephen here with Studyclix, and in this video we're looking at the first 3 rules of indices. So what I'll ask you to do is open your log tables up on page 21, and in the top left corner we'll see these 3 formulas. They're all to do with numbers and powers. So before we get into them, we're going to be looking at numbers in the form a to the power of p. And I just want to tell you, we'll be calling a our base number, and p is what we'll call our power, or sometimes we'll call it our exponent. So when we're referring to the word base, it's the number on the bottom, and then we have our power. So let's look at the first rule of indices. It says if I have a to the p times a to the q, it's equal to a to the power of p plus q. So that first rule means if you're multiplying 2 numbers of the same base, you add the powers together. So a couple of examples might be if I have x to the power of 5 multiplied by x to the power of 6, well, I can add the powers together to get x to the power of 11. Similarly, you could have, say, 2 to the power of 7 times 2 to the power of 3. Well, we're going to add the powers together there to get 2 to the power of 10. Looking at our second rule of indices, if I have 2 numbers of the same base and I divide them, say I have a to the power of p divided by a to the power of q, well, that becomes a to the power of p minus q. We subtract the powers instead of dividing. So say here I had x to the power of 9 divided by x to the power of 5. I subtract my powers here to get 9 minus 5, which gives me x to the power of 4. Finally, what we have, our third rule, is when we have a to the power of p all to the power of q, that becomes a to the power of pq. So pq written beside each other means to multiply p by q. So for example, say I have x to the power of 5 all to the power of 7 here. So what I do is I have a to the power of p all to the power of q. I multiply the powers together to do 5 by 7, which is 35. And another scenario might be if I have 4 to the power of 3 all to the power of 5. Well, what I'm going to do here is multiply my powers. So 3 by 5 gives me 15. So I get 4 to the power of 15. So these 3 rules shortcut all the work for us. The first rule, instead of multiplying numbers, we can add the powers. Second rule, instead of dividing the numbers, we can subtract the powers. And third rule is when we have a power to a power, we multiply the 2 powers together. Let's throw these rules into some busy questions. We're asked to simplify the following. In part A, I have x squared multiplied by x to the power of 4 all cubed. So the first thing I'm going to do is deal with the power on a power. So I'm going to do the x to the 4 all cubed. So I'm going to keep my x squared. I'm going to keep my multiply. So when I have a power raised to a power, that's my third rule. I have x to the power of 4 all cubed. My third rule of indices says I multiply the powers together. So that's going to be 4 times 3, which gives me 12. And now I'm at a stage where I have x squared by x to the 12. That is our first rule of indices. When I'm multiplying 2 numbers of the same base, I add the powers together. So what I'm simply going to do here is add these powers together to give me 2 plus 12, which is x to the power of 14. Let's have a look at another. In part B here, I have b to the power of 5 times b to the power of 7 all over b to the power of 4. Well, on my top line there, I'm multiplying 2 numbers of the same base, which is my first rule of indices. So on the top line here, I can add the powers together. So that's simply going to be b to the power of 5 plus 7, which is 12, all over b to the power of 4. Now what I have here is I'm dividing 2 numbers of the same base, and that's the second rule. The second rule says instead of dividing 2 numbers of the same base, we can just subtract the powers. Subtracting the powers, we get b to the power of 12 minus 4, which is just b to the power of 8. Next up in part C, we have y cubed times y squared all to the power of 5 divided by y to the power of minus 1. So the first thing I'm going to deal with is the power to a power first. So what I'll do is I'll keep the y cubed outside. Then I'm going to have y squared to the power of 5. That's my third rule of indices, so I'm going to have to multiply the powers together to get y to the power of 2 by 5, which gives me 10. Then this is all going to be over y to the power of minus 1. Next, what I'll do is I'll work with my top line where I have y cubed times y to the power of 10. That's my first rule of indices. So I'm going to be adding these powers together. So when I do that, I add the 3 and the 10 to give me y to the power of 13, all divided by y to the power of minus 1. Now in this step, what I have is I'm dividing 2 numbers of the same base, so I can subtract the powers. So what I'm going to be doing here is y to the power of 13 minus, and I'm subtracting off minus 1 here. So when I do 13 minus minus 1, that gives me y to the power of 13 plus 1, so I'm getting y to the power of 14 as my answer here. Looking at one more, in part D, I have a fraction, and on the top line, in brackets, I have a cubed times a to the power of 4, all cubed, all divided by, in brackets, a times a cubed, all to be squared. So what we're going to do first is tidy up inside the brackets of the top and the bottom line. So on the top line, inside my brackets that are going to be cubed, I'm multiplying a cubed by a to the power of 4. So instead of multiplying these numbers, I can add the powers together. So that's going to give me a to the power of 3 plus 4, which is 7. Then on the bottom line, I'm going to tidy up inside the brackets before I square it. Now the bottom line, I have a times a cubed. And I just want you to know that on that a, there's a power of 1. If we've a term on its own, the power is always 1. So here I have a to the power of 1 times a to the power of 3. I can add the powers together. So adding together 1 and 3, I get a to the power of 4. Now I'm going to tidy up the top and bottom by multiplying the powers together using the third rule of indices. So a to the power of 7 all cubed, times them together, I get a to the power of 21. Over on the bottom line of a to the power of 4 all squared, so I'm multiplying 4 by 2 to give me 8, a to the power of 8. Now from here, I'm dividing two numbers of the same base, so what I can do by the second rule is subtract the powers. So I'm getting a to the power of 21 minus 8, and when I work that out, I get a to the power of 13. So folks, that's a gentle introduction to your first 3 rules of indices. They're pretty handy to use. If we're multiplying numbers of the same base, we add the powers. If we're dividing numbers of the same base, we subtract the powers. And if we have a power raised to a power, we simply multiply them. Now it's your turn to work on some of these. Pause the video, try these questions out, and check in with the solutions when they appear on screen. In question 1, we're simply following our 3 rules. In question 2, we have some negative powers, so just be careful when you're adding and subtracting your negative powers. In question 3 here, they want us to work with the left-hand side and tidy it up, and when we do that, we get b to the power of 8. We match this up with our b to the power of k to say that k equals 8. Thanks for watching.